Alright, hello everybody, from your favorite artist electronics, Mr. Q12 here. I'm having a new experiment here, this time using this Mosfet here, and my temperature room, the ambient temperature is this 23, a little bit less than 24 degrees Celsius. Usually my room is 25, but yeah, we didn't make the fire today. I have two power supplies. Let me open them up, actually. That one, this is power supply 1, or my variable power supply, which is here on the circuit diagram. This is 10 volts variable power supply 1, so that's 10 volts. Let me get rid of that one. It should be 0, like that. And this other power supply, this ATX PC power supply, and I'm getting 12 volts from here, from this wire that is going there, is going into this switch. When I'm switching it on, is connecting this wire to that wire that is going to the gate of the transistor of the Mosfet. You see it there. The gate pin is bent. This is the gate, this pin here. Drain is in the middle, and source is on the right side. You see, on the negative rail. Everything that is blue is negative, and everything that is red is positive. Making exception that white wire, that is also positive. So this is the circuit diagram. I also made the test already, and that's why I'm making this movie, because a very interesting and successful test that I did here. But first of all, let me present the circuit diagram first. So like I said, this is power supply 1, and this is power supply 2, which is this box here, and it's powering the gate, like I said, through a switch. And from the gate, I'm having a resistor, a 10K, to the ground. You can actually see it here, this blue one. And this is to turn off the Mosfet after I'm disconnecting the power from its gate. Pull down the resistor here to passively turn it off. This is the internal diode of the Mosfet. This is a capacitor that I put it here, this one, and it's 470 microfarads at 25 volts. This capacitor kind of helped stabilize a little bit, but it's not actually mandatory. You can not insert it if you don't want it. Here is the voltmeter, this one, that is connected also on the positive or negative rail. So I'm having these wires, very thick wires, to not have too much power loss in the wires. That's why I'm using a thick cables, thick wires, and I'm connecting them here and here, and pretty much that's, this is a common negative wire from my ATX, my power supply 2, from this one. This blue one is going here, and this is common with this other one that is coming from power supply 1. So that's why I draw this here as well, and it's a common ground for both power supplies. And that's it. This is all the circuit diagram. I hope it's not too complicated. It's actually very simple. Why I put the switch here is I put it there to test the gate of the transistor from switching. So right now I will demonstrate. I actually did all the tests before. This one is not that important. This is important to show you that I started with, originally I started with an 8 volts here on the power supply. Right now it's showing 10 volts and 0 amps. And when I'm switching the gate, it was showing 0.5 amps. And 25 degrees Celsius in the room, probably it was back then. And that's it. This is from how I started, very, very low values. And then I get more smarter, and I've included this digital multimeter voltmeter here, and readings, and also the wattage for the voltage of the multimeter from this, and the amperage that is shown there when you switch on. So that's what this wattage, how I calculated it. This times this equal that. And this is when power supply is off, like it is right now. All the time is kept at 10 volts. 10 volts there. Actually, I found a 10 volts in the datasheet of this IRFZ44N. Actually, a 10 volts specified for continuous driving. But I'm not completely sure if this, what I'm doing here, is actually what they are suggesting there. But this is as close as I could make it. My intention was to figure out how I burned the last two Mosfets from preview experiments. And that's why I set it up to 8 volts in the beginning, and then I rounded to 10 volts. That's how it's looking right now. I'm only turning the potentiometer for the amperage here. Right now, let me actually switch, and there it is, 5.02. Well, it moved a tiny little bit, probably. It was 0, like that. Like that. It's a bit hard. Yeah, good, don't move. Usually those knobs are kind of moving by themselves. And it's exactly this last line that I'm having it here. You see 5 amps. And the digital multimeter was showing 0.166 or 166 millivolts. But right now it's cold. The transistor is very cold, and it is heating up. Most probably to that 166. Right now it's 150. It started even lower than 50, at 40 something. Yeah. So this is 155 millivolts. If I'm switching here, you see, I'm getting a even greater resolution on the reading, but I will keep it on the 2 volts reading here, or 2000 millivolts. It's the same thing. Yeah, there it is, 160 and 6, and it will rise up to that value quite quickly. If I'm switching a bit too more often, it will increase the temperature. It will increase quite dramatically. Last time I had 53 degrees Celsius because most probably because of the switching that I was performing here. So right now, if I'm switching off, that will go to 10 volts. You see? And now when I'm switching on, back there, it's switching to 5 amps. So in the moment I'm switching, I'm making this switching on the gate. I'm increasing the temperature a tiny little bit. You see? I switch it off now and now on, and it should increase. No, it didn't. Now off, increase a little bit. Now on again, and every time it did switch correctly. You see? Pack, zack, pack, zack. By the way, this 5 amperes, 5. Yeah, these 5 amperes that I'm having here, I'm keeping this power supply in short circuit right now. That's actually the protection of the power supply at 5 amps, because this is literally shorting through the Mosfet, and the Mosfet is not opposing almost any resistance to 170 there. Yeah, so it's probably from the switching there. I'm not sure. I didn't made a too longer time experiment, so I kind of rush it to check to find the problem. So now practically when I'm filming here, I'm actually making the time test, endurance test of this Mosfet, and now I see that this voltage is increasing for some reason. I'm not sure why, but is 10 millivolts over that value that I've written it there, 166, and this is 176 now. It's not that drastic, but let me actually show you the calculation, at least for that data that I collected it there. So 5 volts times 0.166 equal 0.83, and that's the wattage. You see, that's the wattage per transistor per Mosfet, specifically per Mosfet, with the amperage that I'm collecting from this power supply that I'm seeing it there. It should be most probably the same amperage inside this transistor. Why I wanted to make this movie actually was because what my friend said, and right now I'm confirming what he was saying to me, is that a Mosfet is used exclusively to switch a lot of amperes, pretty much. And this is a huge deal. This is a very important rule for Mosfets. The whole point is to not have this problem with the wattage. The whole point is to get the amperage, a lot of amperes switched. So this a Mosfet is an ampere switcher, is switching amperes, a lot of them. And in this case, I managed to switch 5 amps. I'm also keeping a track or an eye on the wattage here, and I'm very close to 1 watt dissipation over the Mosfet, and I'm getting this higher value here. So let me calculate this new value. So 5 times 0.1 watt change equal very close to 1, very close to 1 watt. So 0.925 watts. I'm not completely sure how much wattage you can dissipate over this Mosfet until you burn it, because I had the problems in my last movie when I burned them. My suspicion is that I had a bigger voltage here than I'm having it right now. So most probably I was having this knob, this is the voltage knob, turned to, let me actually switch it off here. So right now we are getting back to voltage driving here, and probably I was having it more than 10 volts, like 15 or 20 volts, like that. And when I switch it on the Mosfet at this voltage here, let me turn it back because I don't want to make the same mistake like the last time. But I showed you, if I'm having it like 20 volts or more than 10 volts, probably, this is my suspicion. And I will conduct more experiments about it to find out the issue and the problem with this voltage here. Because right now when I'm switching, I'm actually switching that maximum of amperage here. You know, and in the last movie, most probably I had it too much voltage here, too much voltage that it was switched, and when it switched from too higher energy voltage to the bigger amperage that was doing that thing inside it, most probably that put a terrible stress over the Mosfet. It is my impression for the moment. I don't know for sure if I'm right or wrong. I might be wrong, but we will see in the future if I'm correct. But for the moment, I want to show you that this Mosfet is capable of switching great amounts of amperage, and 5 amperes is a lot. So let's switch it on and down 5 amps and back and on again. So it is doing the job perfectly right now. Why those other two failed, I have no idea. Now it cooled down, you know. Last time it was 185 and now it's 150 or 148. I told you it was below 150. So yeah, it cooled down when it was not conducting pretty much. So this is another health visualization of the MOSFET. You can see it's how healthy it is if it's lowering the voltage over it. So that's important. The temperature, not really. Most probably all this temperature you see degrees Celsius here, all this increasing was from preview experimentation that I did, and because of multiple switching. And I was seeing actually rising up the temperature quite dramatically while I was switching it here. But right now is not that evident for some reason. Let me actually do a couple of switching. 6, 7, 8, 9, 25, and again, and another switch, and another switch. Hopefully I will not blow up something important. Yep, no, good. I was afraid I blow it up, but let's see. No, I am blowing it up probably. Holy fucking shit, I didn't have the probe over it, that's why. And this is, oh shit. It is smoking. Oh shit, look, holy fucking shit. Oh fuck. Let's see. Shit. Oh, what an idiot. Holy shit. Yeah, it made some... Yeah, I totally forget. Holy shit. I'm blowing air over it. And it made some... You see some bulbs on top of it. And it literally desoldered itself from the heat. Shit. Oh shit, let me close everything off. Hopefully I didn't burn it. I soldered it back. I put the probe, thermic probe right now on it. Let's see if it's even working anymore, which it will be a great deal. It will be awesome if it will work. No, it's burnt. Oh shit. Yeah, he gave its life. Live. It did smoke. I've seen the smoke. So it's even smoking. It's smelling right now. I can smell it. Although there is not showing anything that is doing, but here is increasing the temperature. Huh? I can smell probably a little bit remained there. Yeah, well, you give your life for the science, but you did a great job. He did a great job, actually. Yeah, this was totally my mistake, stupid mistake. Let me actually switch it. Let's see even more to see if. So this is not needed anymore. Yeah, I totally blew it. Anyway, but the idea is that it is capable of switching great amounts of amperage. That's the idea. And in the same time, you had a little bit of show of how to burn a MOSFET by not keeping an eye on, by not keeping a thermic probe over it. You see how important it is. All right, this was totally my stupid mistake here. I was talking and I didn't think about it at all. But I will change it very quickly and check this out. Oh, it was not making contact. Hold on. Okay, so in the moment I will connect this with that, I will get a voltage here and also there, which it shouldn't. Let's see if I can do it with one hand here. So this is another failure mode. Yeah, you see 2 volts with 5 amps. 10 watts pretty much, exactly 10 watts. And I was getting to 0.83 here. And the gate is not open, it's closed right now. I didn't leave it open. I closed the gate and it is still passing current through it. Doesn't matter what the gate is doing, if it's off or on. And also I'm getting a voltage here as well. Yeah, 1.3 and that 1.7 this time. And let's open the gate. So now I'm opening the gate and also the same result, 1.34. And that will increase exponentially probably. It will melt my little plastic clip that I'm having here. So yeah, definitely is busted. and also uncontrollable because I cannot control its gate anymore. But this is another failure. This is another interesting failure of this MOSFET. The point of failure is when I'm switching it on and off. That's the point of failure. It's my impression. Yeah. Okay, that's it for this episode. I hope you were entertained with this failure number 2 of the MOSFET. The idea of this entire movie was to show you that the MOSFET is an amperage driving component. So you can drive a lot of amperage through it. Of course, being careful not to burn it like I did right now, and being careful on the switching parameter there. It must have some protection here for the switching side on the gate, for the gate side, some sort of protection. I'm not completely sure, or some sort of protection I need for it not to get that overwhelming increasing in temperature, and also when it's increasing in temperature, also the voltage here is increasing as well. So the wattage will increase on it, and it will start to fail. But that was definitely from the switching, the failing. It was from the multiple switching when I was playing like that. Okay, that's it for this part. Yes, right now I will switch this burned transistor with another one, with a brand new one, and I want to show you that I'm not shy of this IRFZ44 Mosfets. I have quite a lot of them, 100 I took, specific for testing and to play with them, basically, and in the end to actually build something interesting. But I wanted to show you my box of guys. They are not that expensive, they are quite cheap. It's the proper light, you see, compared one next to another. So this is definitely burned, and you can see some scorched material, some scorched paint, or the actual metal. It's scorched and bubbled like that. I'm not completely sure what is happening there, but it's looking like a bubbled paint of some sort, or maybe this is the actual metal, who knows. But we can see some burned margins. You see these margins are definitely brown, burned. Yeah, very interesting. Nothing on this face, no hole with a burn mark. Usually they get that hole, a little hole, but I swear I've seen a smoke coming from it. You see some interesting patterns here from burning. So I have his brothers there. Those were unknown, but this was a stupid mistake. This was definitely a stupid mistake. Hopefully I will not do the same mistake here, because I will be way more careful this time with this one. And voila, the three musketeers dead. The three dead musketeers. Right, and the new Mosfet is already placed there. Also the probe, I didn't forget it this time. I was looking at this open thermometer here, and I was thinking, when I'm having it open like this, I have the probe connected, but for some reason I totally ignored the probe was out, the last time. All right, let's do the experiment right now. With this experiment, with this brand new, this Mosfet number 4 here, I will show you the increase in temperature while I'm switching, and probably it will increase by itself. Let's go directly to 5. There. Okay. And on 5, the last time I had 0.166, and the temperature was 53 degrees. So this should rise to 53, and this to 166. Yeah, it's still creeping up. Fantastic. This shit is not stabilizing. Fantastic. Let's perform some switching, because yeah, it's stabilized somewhere around 50. Okay, and around 160 millivolts here. Let's do some switching and keep an eye on both of them in the same time. And let's see, zack, and that switch to 10 volts, and zack, and it's 5 amps there. So we will do this, zack, zack, 50, 160, zack, 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 zack. Okay, zack, 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 zack. Not that much increasing here. Very strange. Very, very strange. Very strange. Why the fuck? There, it is doing the job. You see? This is on, off. On, off. No problem. But here is not increasing. I wanted to show you how it's increasing the temperature. Why the fuck you are not increasing? Huh. Shit. It should have been increasing. Wow. Wow. Fantastic. Yeah, there it is, there it is, there it is. Oh, opa, opa, opa. It just decided to He just decided to give up, huh? It is definitely needing something else than this capacitor. This capacitor is not good enough. Probably I burned this one as well. Motherfucker. Yeah, 3. Oh, shit. So, number 4 is done. So, when I'm switching here, definitely it is creating something, some sparks probably inside it. And it is holy fucking shit. Okay. Yeah, I definitely need a better way of protecting the MOSFET from the switching. But what? I don't know yet. We will discover the solution in time. All right, that's it for this part. Thank you very much for watching. Bye bye from your favorite artist electronist here, who burned 4 MOSFETs today in his stupid experimentation. It didn't smoke out, but it definitely got yeah, it got damaged. Okay, bye bye from your favorite artist electronist here, Mr. T12, and see you later. Au revoir. Bye bye. Leave a like.